2010 Canadian Open Mathematics Challenge, Part B. In each part of this problem, each of the variables in the grid is to be replaced with an integer. The sum of the integers in a row is given to the right of the row. The sum of the integers in a column is given to the bottom of the column. For example, from the grid to the right, we can conclude that x plus 13 is equal to 30, y plus 11 is 23, x plus y is 29, and 13 plus 11 is 24. Determine the value of c. All right, so we are now working with that guy, so we can tell you that 2a is equal to 50, so that means a is 25. Entirely based on the explanation they gave me in the opening stem. And then, I guess from that column, a plus c is 57. Since a is 25, we have 25 plus c is 57, and therefore c will be equal to 32. That takes care of part A. Part B, determine the value of n, the sum of the integers in the second column. So here's n right there. Okay, well, from the first row, I get that 3d is equal to 30, so therefore d is equal to 10. And then where do you want to go next? I guess just these two columns will give us a couple equations, and we can add them. So 2f plus e is equal to 55, and then f plus 2e is equal to 50, and then when you add them all, it's 3f plus 3e is equal to 105. And then if we factor out the 3, it's f plus e is equal to 105, and therefore f plus e is 35. All right, and then from the, let's say, where do we want to go? I guess this one, that column, d plus f plus e is n. And d we got is 10, f plus e is 35, and therefore n will be equal to 45. So that takes care of part B. Part C, determine the value of p plus q. So from the first row, p plus q plus t plus r is 20. And then from the third row, 3r plus t is 33. So therefore, we can isolate for t, and we get 33 minus 3r. Let's see here. I guess I can sub that back into here. So that would mean p plus q plus 33 minus 3r plus r is equal to 20. So that means p plus q minus 2r is minus 13. All right. If I can get the value for r, then I can calculate p plus q. So this will be an important equation. We'll save that for a little later here. I'm trying to get now the value for r. Okay, where can I go to get that? Well, 3r plus t is 33, and then we isolated for t, so that helps. If I can get something else in terms of t, I think I'll be able to figure this out. So 3t, this one right here, that one will help you. So 3t plus r is 19. So that means that r is equal to 19 minus 3t. Yeah. Or you can just put in this value in here. Either way. I think I'll just do that. So 3 times t, which is 33 minus 3r, plus r is equal to 19. So multiplying this, we get 99 minus 9r plus r is 19. So that means 80 is equal to 8r, and therefore r is 10. All right, great. Plug it back into there. So p plus q minus 2 times 10 is negative 13. So p plus q is negative 13 plus 20, and that is 7 for the value of p plus q. The parabola with the equation y is equal to x squared minus 4x plus 12 intersects the line with the equation y is equal to minus 2x plus 20 at points A and B. Determine the coordinates of points A and B. All right, I guess we just have to set them equal to each other. So x squared minus 4x plus 12 is equal to minus 2x plus 20. And then that's it. And solve. So let's see here. Put everything on one side. So x squared minus 2x minus 8 is 0. And I think this factors. Let's see. We've got x, 4, 2, minus, plus, right? So x is equal to 4 or negative 2. And then, of course, we want the y value. So I guess I can plug it back into either one of those. And when I do, y is going to be 12 and 24. So my coordinates are 4, 12 and minus 2, 24. Yeah, 4, 12 and minus 2, 24. Okay, great. That takes care of part A. Part B. Determine the coordinates of the midpoint M of segment AB. Okay, well, that's pretty straightforward. You just use the midpoint formula. So 4 plus negative 2 divided by 2, and then 12 plus 24 divided by 2, and that is 1 and 18. So that is the coordinates for M. That takes care of B. C, a line segment, line parallel to the line with the equation y is equal to minus 2x plus 20 intersects the parabola at distinct points P and Q. Prove that P plus Q is 2. All right. So there's some line that's parallel to this line. So if it's parallel, it has the same slope. So its equation would be y is equal to minus 2x plus b, because I don't know what b is. But I know that the slope is minus 2 because it's parallel to that line. Okay, so that's the first part. Then they're saying it intersects that parabola. So the parabola is the same equation, which was y is equal to x squared minus 4x plus 12. Okay, so same story, I guess. We just have to set these equal to each other to get the intersection points P and Q. And then we have to show that this P and this Q add up to 2. Okay, so let's take it this one step at a time. Let's just first figure out the intersection points. Put everything on one side and get x squared minus 2x plus 12 minus b. Okay, so we're going to have to use a quadratic. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, which is 1. So this is 2 plus or minus 4 minus 48 plus 4b all over 2. So this will be 2 plus or minus the 4 we will be able to take out, and that becomes a 2. And it will leave us with b minus 11. Yeah, all over 2. And then the 2's will cancel. It becomes 1 plus or minus b minus 11. Like that. So one of these is p, and the other one is q. So, for example, I guess we can just say that p is equal to 1 plus b minus 11, and then q is equal to 1 minus b minus 11 under the square root sign. So p plus q, if we add them, p plus q will be 1 plus b minus 11 plus 1 minus b minus 11, all under the square root, of course. And that just becomes 2. So there you go. Okay, that wasn't so bad. I thought it would be a little bit harder than that, but okay, no problem. And then finally, prove n, or point n is the midpoint of PQ. Explain why line segment MN is vertical. Okay, so I think I have enough space to squeeze it in here. So N is the midpoint of PQ. All right, so what is P and Q? Oh, it's up here. Okay, I got it. Okay, so we have to show that N, which is the midpoint, and then Mn is vertical. Okay, so first of all, we got to figure out what is the midpoint. N is the midpoint. So using the midpoint formula, P plus Q over 2, and then this big whole thing, P squared minus 4P plus 12 plus Q squared minus 4Q plus 12, and all over 2. All right, great. And then N is going to have those coordinates, but M are these coordinates up here, which is 118. Now, P plus Q, we had proven, was 2. So this is going to be 2 over 2, which is just 1. And then this big whole long thing. Well, I'll just put that symbol. So we have to now show that line segment MN is vertical. Vertical meaning going up and down. If that's the case, then if it's going straight up and down, then that means that it has the same x coordinate, right? Any 2 points on that line would have the same x coordinate, right? If this is like the x-axis and this is the y-axis, if a line is vertical, any 2 points on that line would have the same x coordinate. Now, let's say this is N and let's say this is M. Well, they do indeed have the same x coordinate, right? The coordinates for N are 1 something. We don't really care what the y coordinate is. And the coordinates for M are 1 and 18. So since they both have the same x coordinate, that line NM is indeed vertical. And you can write that out in a sentence format. In the diagram, the circle has center O, the diameter AC, and a radius of 1. A chord is drawn from A to an arbitrary point B, different from A, on the circle and extended to point P, with BP equal to 1. Thus, P can take many positions. Let S be the set of points P. A. Let U be the point in S for which UO is perpendicular to AC. Determine the length of UO. Okay, so UO is perpendicular to AC. So that means I'm going to have to draw some lines in here. So basically this is the situation where this is the U up here, this point right here, and UO is perpendicular, so this is a right angle. And because they had given us an example where when you draw that line, the point where it crosses the circle is B, this is now my new B. And they also tell me that BP is 1. So based on that principle, this B to U will also be 1. And then from the top of the circle here to U, that I don't know. So I'll just call that X, that distance from here to here. But I do know that the radius of the circle is 1. So that means this distance is 1. So let's just put that in there, 1. And this is also 1. Okay, I think that should be enough. Yeah. All right, so we have to label some angles and then do some angle chasing here. I'm going to draw one more line. Hopefully it's not too confusing. I'm just going to draw one line from B to O to connect it like that. And then we can now figure this out. Okay, so the angles, this angle in here, I'm going to call theta. And since the distance from here to here is 1, and the distance from B to O is also 1 because that's representing a radius, this is an isosceles triangle, so therefore this is also theta. And then therefore this angle in here would be 180 minus 2 theta. 180 minus 2 theta. And then this angle, because the sum of the angles about a line are equal to 180, this angle would be 2 theta. This angle right there. And then interestingly, we have another isosceles triangle. This is 1, and this is also 1. So therefore, this angle must also be 2 theta. And then finally, this angle will be 180 minus 4 theta, since the sum of the angles of a triangle are 180. Okay, so now finally we can concentrate on those two angles. They have to add up to 90, since that's a 90-degree angle. So 90 is equal to 180 minus 4 theta plus theta. So that means that's 3 theta is equal to 90, and therefore theta is 30. Okay, great. So I don't want to make that too messy. If I draw that triangle again, where this is U and this is O and this is A, that basically means that this is 30 and this is 60. So that is a 30, 60, 90 triangle. Okay, well, the ratio of the sides of any 30, 60, 90 triangle are 1, 2, and root 3. Well, we know that this side is equal to 1 in terms of its actual length. So therefore, this side must be equal to root 3. So the distance from here to here is root 3. And therefore, what do they want? They want the length of UO. Well, the length of UO is equal to root 3. And if this was on a coordinate axis where O is the center, where O is the origin, U would have the coordinates 0, root 3, like that. Okay, part B. V be a point on S for which VC is perpendicular at AC. Determine the length of VC. Okay, so we can use the same sort of formula, but this time the position is different. So in this part B, we've got this situation where V is now up here, and it's, when you draw that line VC, it's perpendicular to AC like this. So they want you to determine the length of VC. Okay, well, as before, the B is where it crosses the circle. So in our example, it was here, but in our particular case now, B is going to be this guy right there. So that's my B. And then the distance from B to any point on S is 1, right? BP is 1, where P is a point on S. So B to V this time is 1, because V represents a point on S, or in S. Okay, so V to C, I don't know that distance, so I'll just call that distance X for now. And then I do know that the radius of the circle is 1, so that's 1 and that's 1. So that whole side is 2 from A to C. Okay, and then anything else I know? I can join B to C, and if I do that like this, that will help, because any such triangle drawn within a semicircle is right angled. So that's going to be a right angle right there. So that'll help, right? Because that means this is a right angle also. Okay, and anything else? I think that should be it for now. Okay, so let's use Pythagoras. AV squared is equal to 2 squared plus x squared in triangle AVC. So that means AV is equal to 4 plus x squared, all under the square root sign, like that. Okay, then now we have a similar triangle situation. If you can't see those, I'll draw them out. The two triangles that are similar are triangle VBC and triangle VCA. So let's draw them here to sort of prove that they're similar. Sometimes it's a little challenging to look at the diagram. You got V, B, and C. This is a right angle. This is 1, and this is X. VCA is the big one. Again, you've got VCA like that. This is X, this is 2, and this is 4 plus x squared under the square root sign. Now both of these share a common angle, and that is this angle right here. It's part of VBC, and it's also part of VCA. So that means that the third angle is 90 minus theta. So because those two triangles have the same angles, they're similar. So now we can get a relationship between their sides. VC over VA is equivalent to VB over VC from those two triangles, since they're similar. So that means VC squared is equal to VB times VA. VB is equal to 1, and VA is equal to this 4 plus x squared under the square root sign, like that. And VC, actually I call that x. Okay, there we go. Now what I'll do is square both sides, and I get x to the power of 4 is equal to 4 plus x squared. Put everything on one side, and we get this equation: x to the power of 4 minus x squared minus 4 is equal to 0. And if I don't think this factors. Oh boy, so I got to use a messy quadratic. Okay, not a problem. X squared therefore would be minus 1 plus or minus the square root of minus b squared minus 4 times a c all over 2a. So this looks like 1 plus or minus root 17 all over 2, and therefore x is the square root of that, but I can't use the 1 minus root 17 because that would be negative. So I can only use the 1 plus root 17. And then I take the square root of that. Okay, so there we go. That's the coordinate, x coordinate. That's the length, actually, of VC. Okay, there we go. We just got the answer. And if this was on a coordinate system where A is the origin, well, sorry, 0 is the origin, 0, 0, and this is 1, the coordinates of V would be, let's see here, 1, and then the length of top to bottom, which we just figured out, is 1 plus root 17 over 2, all under the square root sign. Okay, great. Determine whether or not there is a circle on which all points of S lie. Okay, so what they're saying is the following. So we have to first try to prove that all those points are indeed on a circle. So I will make an original assumption, and my original assumption is that there is a circle on which all points of S lie. So P is one such point, right? So if I draw this blue line where it's sort of going in the opposite direction, then this would be also a P down here. And if you just keep doing that, like if this line from here to here was also a similar line where this is another B where C is, so right there, then this would also be sort of a P right there. And if you connect all those, we have to show that all of those P's are on a circle. Okay, so this circle, or what I think could be a circle, we will call part of circle, and I'll just call it circle Z. Now, there's a few points that we have to keep in mind. The first is that it looks like it's symmetric about across the x-axis. And then since I drew it on a coordinate grid, I will give it a certain value for the center. The center of the circle, in terms of its x-coordinate, I don't really know, so I'll call it P, but I'm confident that the center in terms of its y-coordinate will be 0, and that's because of the symmetry across the x-axis. So that would be the center. So therefore the equation of this circle would be x minus p squared plus y minus 0 squared for some radius, we'll just call it r. And so there you go, there's the equation. Now, if you look back to part A of this question from 3A, we had concluded that U was one of the points, and we had also found the coordinates of U. It was 0, root 3. And we had also found from 3B that V is a point on this S, and that coordinates we had found was 1, and then 1 plus root 17 over 2, all under the square root sign. So we had to show that these two satisfy this equation. But before we do that, we've got to figure out the numerical values of R and P, because right now we've got some unknown variables. And if once we find out P and R, and then if we can indeed substitute both of these, then that proves that it's a circle. If it doesn't work out, then it's not a circle, and our original assumption would be incorrect. Okay, so here we go. So from this original equation, we have x minus p squared plus y squared is equal to r squared. And I'll substitute this in. That will help. So that would mean that we have 0 minus p squared plus root 3 squared is equal to r squared. So that means p squared plus 3 is equal to r squared. Okay, so that's my first equation. And then I don't want to substitute this in. That's a little messy. I think I can find a better point. This point right here would be helpful. This point right there, this P. Because if this is B right here, then we know for a fact that any distance from B to P is 1. So this is 1. And then from the origin to C, well, that's just the radius of the circle, and that's also 1. So that means the coordinates of P, this P, is 2, 0. So that's what I'm going to substitute in. I'll substitute 2, 0. So sub 2, 0. So we get, let's see here, 2 minus p, I'm substituting in there, squared plus 0 squared is equal to r squared. So that means 2 minus p squared is equal to r squared. And that's equation 2. Equation 1 and equation 2 are therefore the same, therefore they can be set equal to each other. So that means that p squared plus 3 is the same as 2 minus p all squared. Okay, expand, we get p squared plus 3, 4 minus 4p plus p squared, and therefore 1 is equal to 4p. P is equal to 1 over 4. Okay, great. We got a value for p. And I think we can substitute that back into here to get the value for r. So p squared plus 3 is equal to r squared. So that means we have 1/4 squared plus 3 is equal to r squared. So that means this is 1 over 16 plus 3 is r squared. So that's going to be what, 49 over 16 is r squared. So therefore r would be 7 over 4. Okay, great. We've got a nice value. So now let's substitute it back into there. So that means my actual equation is x minus p, which is 1/4, all squared, plus y squared is equal to 49 over 16. So this is the equation of the circle. And then now I will try to substitute this value to see if it works. If it works, then we have shown that this is a circle. If it doesn't work, then it's not a circle. So here we go. So we got 1 minus 1/4 squared plus 1 plus square root 17 over 2. Because when I square it, the radical disappears. And does that equal 49 over 16? All right, let's see. This is 3/4. 3/4 squared is 9 over 16. And then I'll break this up since we have to add this fraction. And then I'll just keep everything on one side in terms of the radical. So this becomes 49 over 16 minus 9 over 16. Get a common denominator, minus 8 over 16. So that looks like 32 over 16, which is 2. And root 17 over 2 is supposedly equal to 2, and obviously that's not true. So this means that since our point, what was it called? V, right? Since V does not satisfy the equation of the circle, our original assumption is incorrect. And therefore, there is no circle on which all points of S lie. Let x bracket denote the greatest integer less than or equal to x. For example, 3.1 bracket is equal to 3, and negative 1.4 bracket is equal to negative 2. For x greater than 0, define f at x to be x plus 1 over x minus x plus 1 over x bracket. For example, f at 4 over 9 is equal to 4 over 9 plus 9 over 4 minus 4 over 9 plus 9 over 4 in bracket, which would be 97 over 36 minus 2, which is 25 over 36. Determine all x greater than 0 so that f at x equals x. Okay. So if x is greater than 0, if we set f at x equal to x, let's see what we get. So this is f at x, so that means that we have x plus 1 over x, and we have minus x plus 1 over x, all under the bracket, and that is equal to x. Okay, so if we put the bracket on the other side, that would mean x plus 1 over x, bracket goes here, and then if we put the x on the other side, it cancels with this x, so you just get 1 over x like that. Now, x is greater than 0. That's very important, because if x is greater than 0, this part will be positive. For example, x is 2. It's greater than 0. It would be x plus 1 over x, which is 2 plus a half, which is 2.5. And when you take the bracket of it, it would drop it down to 2, right? Because 2.5 bracket is 2, because you're taking the smallest, by definition, you're taking the greatest integer less than or equal to x. So therefore, because of that, this part has to be a positive integer, since x is greater than 0. Now, since this is equal to 1 over x, that means 1 over x is also a positive integer. So what that means is that 1 over x is equal to some n, where n is a positive integer. Okay, so let's put that back in to this equation. 1 over x we have called n, and therefore x would be 1 over n, and 1 over x is n. Like that. Now, we have this conclusion that n is a positive integer. So let's try what happens. The smallest positive integer is n equal to 1. So let's see what happens. 1 is equal to 1 over 1 plus 1. 1 is equal to 1 plus 1, which is 2, and obviously that does not hold true. So n cannot equal 1. How about if we try n equals 2? If n equals 2, then our equation becomes 2 is equal to 1 over 2 plus 2, and this is equal to 2.5, and when you take the bracket of 2.5, it indeed equals 2, so that works. How about if we try n equals 3? That would mean 3 is equal to 1 over 3 plus 3, and that would mean 3 is equal to 3.3, repeat bracket, and that is indeed valid, because that would be 3 is equal to 3. And similarly, for 4, 5, 6, it would be the same. So that basically means that when they say determine all x, it is going to be possible this works, namely that f at x is equal to x, when x is equal to 1 over n, and n is greater than or equal to 2, where n is a positive integer. Suppose that x is equal to a over a plus 1 for some positive integer a greater than 1. Prove that x does not equal f at x, but that f at x is equal to f at x. So they are telling us that we've got x equal to a over a plus 1. A is greater than 1. And we have to show two things. First is that x does not equal f at x. And then we have to show that f at x is indeed equal to f at x. Like that. Okay, so let's take it one step at a time. First, let's tackle this one here. F at x, in this case, if we use the definition we were given, with this time x being equal to this, it's going to be f at a over a plus 1, like that. So that is going to be, we have this definition up here, remember? We are going to use that, and that's going to give me the following: a over a plus 1 plus a plus 1 over a minus the same thing, but the same thing in brackets this time, plus a plus 1 over a, and that's in brackets. Okay, so let's bring this over here. So f at x therefore would be a squared plus a plus 1 squared. I'm just adding those fractions, and then that's a plus 1 times a. And then this same thing, the only difference is it's inside the bracket. So a times a plus 1. Okay, so now this becomes, if you expand and collect like terms, 2a squared plus 2a plus 1. And of course, that is going to be the same. And this is the exact same, 2a plus 2a squared plus 2a plus 1 all over a times a plus 1. Okay. So I think we can factor now. If we factor out a 2 and an a, it'll leave me with a plus 1. And then we're just going to have this plus 1 out here. A times a plus 1. And the same story over here, 2a, a plus 1 all over a times a plus 1. And then now, if we break this up, if you have just this over this, that will just leave with 2. And then we can have this 1 over a times a plus 1. And in a very similar way, it would be 2 plus 1 over a times a plus 1, like that. Okay, now keep in mind that a is greater than 1, right? And it's a positive integer. So if a is greater than 1 and it's a positive integer, for example, if it's 2, then what happens is, notice this part would be a fraction. And in the case of a equal to 2, it would be 1 over 2 times 3, which is 6. So that would mean 2 plus 1 over 6, if you take the bracket, would just drop down to 2. And that is the key point here, that this part will always be 2 if a is greater than 1. So that means this would be 2 plus 1 over a times a plus 1 minus 2, and that just leaves you with 1 over a plus 1. And that, if you recall, was f at x. And x was equal to a over a plus 1. And therefore, we have shown that this is not equal to x, because x is equal to a over a plus 1. Now, this is not equal to this, but could it be? Well, let's see. If 1 over a times a plus 1 is indeed equal to a over a plus 1, if you cross multiply, you'd get a plus 1 is equal to a squared times a plus 1. If you cancel the a plus 1s from both sides, you just get 1 is equal to a squared, and therefore a is equal to plus or minus 1. But that's not possible, because our condition was that a has to be greater than 1. So therefore, we have proven that this is indeed true, that f at x does not equal x, because this is essentially f at x. So that takes care of the first part right here. Now we have to show this part, that f at x is indeed equal to f at x. Okay. So now we have to show that f at x is equal to f at x. Okay. So that basically means that f at x, which we have previously shown to be a times a plus 1, has to be equal to f at x, which is 1 over a times a plus 1. Okay, so we have to show this. Now, when we are making the substitution that x is equal to a times a plus 1, keep in mind that our condition is that a is greater than 1. If a is greater than 1, then that means 1 over a times a plus 1 is greater than 0. So what I'll do is I'm going to let this a times a plus 1 equal y, and therefore y is greater than 0. And if you recall from 4a of this question, we had proven that if y is greater than 0, that f at y is equal to y. We had just done that. So that means, therefore, that f at 1 over a times a plus 1, which is what y is equal to 1 over a times a plus 1. Basically this. And that is essentially what this is. And therefore, this is true. So, using our knowledge and findings from 4a, we are able to prove what they want us to prove in 4b.